Welcome to the video for 12.1 Enthalpy Change. You need to look at your textbook pages 164 to 166 to help with this video. Our learning objectives for today are to define the terms enthalpy of formation, ionization energy, enthalpy of atomization of an element, bond dissociation enthalpy, electron affinity, lattice enthalpy, which can be defined as either lattice dissociation or lattice formation, enthalpy of hydration, and enthalpy of solution. So today's lesson is quite straightforward. It mostly involves just learning some key definitions. However, before you watch the video and before you start this topic, it's a good idea to go back and look at the AS level energetics that you studied, because if you don't understand that, then this unit is not going to make any sense. So if you haven't already, go back and just have a quick look over all the terms and the calculations that you did in year 12. So, quick bit of revision before we start with the main definitions. So enthalpy change is a heat change at constant pressure. And the standard conditions that we use are 100 kilopascals and a stated temperature, which is normally 298 Kelvin. So on the next few slides I'm going to show you some key definitions. Now it's important that you learn these word for word, because if you are asked these in an exam question, then missing out a word or putting an extra word in can make all the difference between you getting the marks and not. So the simplest thing is just to learn them word for word, so that when you ask for them in the exam, you write them down exactly how they should be. Definition questions should be easy marks in the exams if you've done your revision and you've learned your stuff. And the other reason you need to know them is if you don't know the definitions, then you can't use them in the Born-Haber cycles, which we're going to look at next lesson. So you have to know your definitions, because if you don't know your definitions of these terms, you can't use them. So here's our first definition that you need to know, which is enthalpy of formation. And you've met this symbol delta here, this triangle here before. That just means change. You should be familiar with the fact that H, capital H, means enthalpy. This symbol here, theta, means standard conditions, so that implies that the enthalpy change has happened under the standard conditions that we talked about. And then the F just means F for formation. So the definition that you need to know is the enthalpy change when 1 mole of a compound is formed from its constituent elements under standard conditions, all reactants and products in their standard states. So I've given you an example here. So an example would be carbon, and in its standard state it would be solid and it would be graphite. You then react in that with 2 hydrogens, and the hydrogen molecule in its standard state is a gas, and then on the right hand side you've got methane. You've got CH4, and that is a standard state, is a gas. So that would be your enthalpy of formation for methane. So ionization energy you've met before, so you should already know the definition, but if you don't, you need to learn it now. The first ionization energy, which we write as the first IE, is the standard enthalpy change when 1 mole of gaseous atoms is converted into a mole of gaseous ions, each with a single positive charge. And we can represent this for magnesium by Mg with a G symbol, giving Mg plus with a G symbol plus electron minus. Our second ionization energy, which is second IE, is the standard enthalpy change when 1 mole of gaseous unipositive ions is converted into a mole of gaseous dipositive ions. This is quite commonly written wrongly in exam questions, because students don't start from the unipositive ion, they start from an atom. The second ionization energy, you have already got a unipositive ion, so in this case you've already got Mg plus and you're making it into Mg2 plus, so make sure you get that straight. So the next one you need to know about is the enthalpy of atomization of an element. Now we represent this again with a delta H and the theta symbol to show that it's standard conditions, and then AT. Make sure when you're writing abbreviations, the only abbreviations you should use for these terms are the ones that are given on these slides. Do not use any other abbreviations, otherwise you won't get the marks in an exam. So the enthalpy of atomization is the enthalpy change which accompanies the formation of 1 mole of gaseous atoms from the element in its standard state under standard conditions. So for example here for sodium, we've got Na as a solid going to Na as a gas. This next term is one you've met before, the bond dissociation enthalpy, which is also the mean bond enthalpy. And this is the enthalpy change when 1 mole of gaseous molecules each breaks a covalent bond to form 2 free radicals averaged over a range of compounds. And we've met this at AS, so if you've gone back and looked at your AS, you should be familiar with this. Electron affinity is the next definition you need to know. And again, you've got this delta H symbol with the theta for standard conditions, and it's an EA that represents electron affinity. So the first electron affinity is the standard enthalpy change when a mole of gaseous atoms is converted to a mole of gaseous ions, each with a single negative charge. So in this case, you're going from Br as a gas, you're adding an electron to it, and it's becoming Br minus as a gas. So the first electron affinity is going from an atom to a negatively charged ion. The second electron affinity is the standard enthalpy change when a mole of electrons is added to a mole of gaseous ions, each with a single negative charge, to form ions each with 2 negative charges. So this is like the first ionization energy and the second ionization energy. When you have the second ionization energy, you're already starting from a M+. So in this case, with the sulfur, you're not going from sulfur to sulfur 2 minus, you're going from S minus to S2 minus. So you're starting off with an already negative ion, and you're making a doubly negative ion. So in this case, it's S minus as a gas, plus 1 electron, giving S2 minus as a gas. The next one you need to know is lattice enthalpy. Now this can be defined in 2 ways. You can either have it as the lattice dissociation enthalpy or the lattice formation enthalpy. You will have the same value for both of those figures for a certain compound. However, they will be oppositely signed. So the lattice formation enthalpy, which we represent by this delta H theta L, that is the standard enthalpy change when 1 mole of solid ionic compound is formed from its gaseous ions. So the clue is obviously in the name, it's the lattice formation. So it's the formation of the lattice. You think about ionic compounds as being a lattice. So it's a lattice coming together. And it's coming together from being the gaseous ions. So for magnesium chloride, for example, you would have Mg2 plus as a gas plus 2Cl minus as a gas to give you MgCl2 as a solid. Now if you had the lattice dissociation enthalpy, it would just be the opposite. So it would just be MgCl2 as a solid, giving Mg2 plus as a gas, plus 2Cl minus as a gas. So make sure when you're in an exam question that you're making sure you're writing the right one. Next we have the enthalpy of hydration, which is a delta H theta and an HYD. And this is a standard enthalpy change when water molecules surround 1 mole of gaseous ions. Now you may not have seen water written before in an equation like this. It's a bit unusual. We only do it for enthalpy of hydration and enthalpy of solution. But it's because we don't want water in the equation, because otherwise it's going to disappear on the right hand side. So we write it like this with Mg2 plus as gas plus AQ, which represents water, to give Mg2 plus, which is now aqueous. Lastly, we have the enthalpy of solution, which is again delta H theta and then SOL. And this is the standard enthalpy change when 1 mole of solute dissolves completely in sufficient solvent to form a solution in which the molecules or ions are far enough apart not to interact with each other. So you're starting with an ionic solid, in this case, and you're adding it to water, and it's becoming completely dissolved. So again, we've got this funny AQ on the left-hand side of the equation because we can't put water there because then we wouldn't have it on the right-hand side. So we've got MgCl2 as a solid plus AQ goes to Mg2 plus aqueous plus 2Cl minus aqueous. It's important not to get the enthalpy of hydration and the enthalpy of solution mixed up. Students often get these mixed up, so make sure you learn the definitions and you don't get them mixed up. So now here's our learning objectives, which were to define the terms enthalpy of formation, ionization energy, enthalpy of atomization of an element, bond dissociation enthalpy, electron affinity, lattice enthalpy, enthalpy of hydration, and enthalpy of solution. If you can't meet that learning objective, then go back and rewatch the video, look at your textbook, look at your online notes, whatever you have to do. You need to learn all of these definitions before you come to the next lesson.